Okay, so having defined ordered pairs of having defined ordered pairs, having defined the Cartesian product of two sets, now we are going to define relation between two sets. We have to define relation between two sets. We are defining relation between two sets. So think of two sets here, two non-empty sets, A as A, B, C, D, and think of B as 1, 2, 3. Now I write A cross B. Let me write A cross B. And you know what will be A cross B? It will be A1, A2, A3, A3, B1, B2, B3, C1, C2, C3, D1, D2, D3. So we have here A cross B. I repeat again. What are we going to learn? We are going to learn relation between two sets. Relation between two sets. We are going to define relation between two sets. So here, what are the two sets? The two sets are A and B. Then what I did, I went for A cross B. I could have gone even for B cross A. That is also possible. But let us now first have A cross B. Now what I do is I write few subsets of A cross B. Try to get this here, students. I'm writing few subsets of A cross B. Now you understand that what is subset of a set? I have A cross B. This is A cross B. This is Cartesian product of A and B such that the elements of set A are the first component. I'm writing few subsets of A cross B. So say I write here A1, A2, A3. That's it. I wrote only this much. Is this set a subset of A cross B? Yes. Yes, it is a subset of A cross B. Remember, if I wrote a subset of A cross B, if I wrote a set which is subset of A cross B, I will say this set is a relation from set A to set B. What I will say this set, okay, I will say this set is a relation from set A to set B. Why say relation from set A to set B? Because it is a subset of A cross B. This is A cross B. So you will always say relation from set A to set B. You will not say relation from set B to set A. You will not say that. You will not say relation from set B to set A. You will not say that. Why? Because here you have A cross B, whose subset you have written. You have not written the subset of B cross A. When you would write the subset of B cross A, you would say relation from set B to set A. Okay, now you might have a question that we wrote a subset of A cross B. We can write many subsets of A cross B. Okay, you are right. I can write many subsets of A cross B. See, I can write A1, B1, C1, D1. See here. This is also a subset of A cross B. This is also a subset of A cross B. Why? Because all the elements in this set are there in this set. So this is also a subset of A cross B. Yes. So what I will say this set is a relation. It is a relation from set A to set B. Yes, you will say like that. If you have a question that we can have many subsets of A cross B. So are we going to have those many relations from set A to set B? Yes, you are right. You can have many subsets of A cross B. So you will have those many relations from set A to set B. Remember that. So if you now have a question that how many relations are we going to have? How many relations are we going to have from set A to set B? If you want to know the answer of that, then you should first be able to write how many subsets do you have from set A to set B? How many subsets do you have? How many subsets do you have from set A to set B? How many subsets do you have from set A to set B? So the total number of subsets of A cross B. How many subsets do you have of A cross B? Total number of subsets of A cross B. Number of subsets of A cross B equals to 2 raised to the number of elements it has. How many elements it has? 12. 2 raised to 12. You will have these many subsets of A cross B. You will have these many subsets of A cross B. 2 raised to 12. You know 2 raised to 10 is 1024. So 2 raised to 11 will be 2 raised to 10 is this. So multiply 2 raised to 2. That is 1024. 1024 into 4. That is equal to 4096. These many subsets you will see, like I have written 1, 2. I have written 2 subsets before you on the screen. So like this, you will have to write more 4094 subsets. 4094 more subsets of this A cross B could be written. And remember, if those are subsets of A cross B, they are relations from set A to set B. This is the definition of relations. This is the definition of relations between two sets. So I can have many relations from set A to set B. This is one relation. I will call it as R1. This is another relation. I can call this as R2. You know, there will be, as I said, that here we will have 4096 subsets of A cross B. So it means I will have 4096 relations from set A to set B. Yes, I have written 2 relations, R1, R2. R1 and R2. R1 is a relation from set A to set B. R2 is also a relation from set A to set B. Now let us take the discussion ahead. R stands for relation. Remember, students, a relation from one set to another set is also a set. That one has to understand. So I will make a note here. I will write here a relation from one set to another set. A relation from one set to another set is also a set. Is also a set. Let me now give you the definition. Yes, that is true. See here, it is also a set, a relation from one set to, I wrote this to twice. It is set. From one set to another set is it is also a set. You can check a relation from set A to set B. What is it? This is also a set. You check. This is also a set. A relation from another relation here. See, this is also a set. It is what? Set of ordered pairs. Rather, we should be more precise to write here a relation from one set to another set is also a set, and rather it is set of ordered pairs. A relation from one set to another set is also a set of ordered pairs. You can check. What you noticed? You notice that a relation is also a set of ordered pairs. See here. What is the relation? It is set of ordered pairs. Now I will give the formal definition of relations. Let me now give you the formal definition of relations. I write here. A relation from set A to set B, a relation from set A to set B is a subset of A cross B. Is a subset of A cross B. So here in this above example, we can write here in above example, R1 is a relation. R1 is a relation from set A to set B. And we can write, therefore, R1 is a subset of A cross B. Remember this. R1 is a subset of A cross B. Same is the case you can write with R2. What you can write? You can also write R2 is a relation from set A to set B. So you can write R2 is a subset of A cross B. Next. Remember students, like here, let me just copy these two once again. R1 is A1, A2, A3, and R2 is A1, B1, C1, D1. Okay, so let me just copy this, or I'll have to again and again go to those screens. So here I write R1. What was R1? R1 was A1, A2, A3, A1, A2, A3, and R2 I have is A1, B1, C1, and E1. So as I said that a relation from one set to another set, remember, it is also a set of ordered pairs. A relation is also a set of ordered pairs and has to be because it is the subset of a Cartesian product set. It is a subset. It is a subset of a Cartesian product set. Now see what I will write. I notice that A1 is a member of relation R1. See A1. Look at the element A1. A1 is member of relation A comma 1 is a member, it's an element of R1. So here we will say that A1, see, we can say A1 belongs to R1. This is one way of writing, okay? Or we can simply say AR1 1. See what I'm writing? I'm writing A, then I'm writing in between A and 1, which are the two components. See, I'm writing R1. So what does it mean? It means that the element A, the first component A, which is from set A, is related to the second component 1, which is from set B, by the relation R1. So AR1 1, AR1 1. This is also a way of writing. You can write, see, you can either write that A1 belongs to R1. This is how you know it. Or you can simply write A1 R1 1. A1 R1 1. A1 R1 1. Same way here, say B comma 1. What do you have? You have B1 belongs to R2, or you will write B R2 1. You can write B R2 1. Next, see here D1. You can write D comma 1 belongs to R2, or you can write D R2 1. DR21. What does it mean? It means that the element D is related to 1. I'm sorry, this is not R1. I made a mistake. It's R2 that I wanted to write. D1. See, D1 belongs to which relation? R2. So I wanted to write R2 here. This is R2. I'm sorry. So what is meaning of DR21? DR21 simply means that D comma 1 is an element of relation R2. It means that the number D is a number. So the first component D is related to the second component 1 under the relation R2. Under the relation R2. That is what it means. Okay, now let's go ahead a bit. So here, think of a non-empty set. Consider a non-empty set A. So A is a non-empty set, and what I do now is, see, it's a non-empty set A. I define a relation, okay? A relation defined from set A to set A. Now try understanding this. What is happening? Try to understand. Normally what happens is you define a relation from one set to another set. You see this, from one set to another set. Now in this case, what is happening? You are defining relation from set A to set A. It means there is no there is no set B. There is no second set. There is just one set. Now remember students, when you define a relation from set A to set B, when you say the relation from set A to set B, you know that such a relation is a subset of A cross B. It is a relation, it is a subset of A cross B. It means a relation which is defined from set A to set A will be a subset of A cross A. A subset of A cross A. Okay. So let me now take you ahead with this statement. See, I will write, consider a non-empty set A, and then I will write the Cartesian product of the Cartesian product of set A with itself is given by A cross A. It is given by A cross A. It is sometimes also denoted by A square. So the Cartesian product of set A with itself is given by A cross A. It is sometimes also denoted by A square. See, for example, suppose I have here A as 1, 2, 3, 4, 5, and 6. What I have A as 1, 2, 3, 4, 5, 6. I want to find A cross A. What will be A cross A? Try to get this. A cross A will be the Cartesian product of A with itself. A with itself. So how I can help you is, I can help you by writing A twice. I can help you by writing A twice. 1, 2, 3, 4, 5, 6. What does it mean? It means you now have to write the Cartesian product of A with itself. So normally what you have one set A and the other set B. Then you take the first component of A, second component of the ordered pair as B, like this. Okay, but here it is A cross A. So how would it be? It would be this way. See, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. See, 1 from here, 1 from here, 1 from here, 2 from here, 1 from here, 3 from here, like this. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then now you will take 2 from here and the 6 elements from here. Okay, so you will have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. What do you have? You have 36 elements here. You have 36 elements in A cross A. This is also termed as A square. Okay. This is known as the Cartesian product of set A with itself. What is this? It is also known as Cartesian product. It is also known as Cartesian product. Cartesian product of set A with itself, with itself. Okay, A cross A. You don't have two sets here. You are taking Cartesian product of one set with itself. Now see. So what I was saying consider a non-empty set A. The Cartesian product of set A with itself is given by A cross A. It is sometimes also denoted by A square. See, I define a relation on such a set. I define a relation from set A to set A. What I do? I define a relation from set A to set A. Try to understand, students, that since I have here just one set, I have here one set. So I don't have two sets. Normally, when I have two sets, A and B, I say the relation from set A to set B. And in that case, the relation which I define, it is a subset of A cross B. Now here what is happening? I have just one single set. So I would be saying a relation from set A to set A. I'm saying the relation from set A to set A. In such a case, the relation which I define, it is a subset of A cross A. It is a subset of A cross A. And remember, students, such a relation is known as a binary relation. It is known as a binary relation on A. If you are defining a relation on a set, you rather what you will say? You will say that we are defining a relation on set A. Because see, instead of saying relation from set A to set A, instead of saying relation from set A to set A, see, this doesn't sound good. From set A to set A doesn't sound good. Yes, it would sound good if you say set A to set B. But then when you say from set A to set A, it doesn't sound good. What we say relation on A. Remember, students, we will call this as relation on A. So what I will say R1 is a relation defined on set A. I will say R1 is a relation defined on set A. What does it mean? It means R1 is a subset of A cross A. R1 is a subset of A cross A. So I will write this in detail here. When we define a relation from set A to set A, we normally call such a relation as relation on set A. We call it as relation on set A. Such a relation is a subset of A cross A. Such a relation is also called a binary relation on set A. So remember, students, whenever you come across a term binary relation, you should understand that such a relation is defined on a set. There are not two distinct sets. There are not two distinct sets. There is just one single set, and the relation is defined on that set. That is, first you will have the Cartesian product of that bigger set with itself, and the relation is defined on that set. That is, the relation is a subset of that Cartesian product. And such relation you will call that as binary relation. Okay, like here you saw I have A, and then this is A, you can call it as a parent set. This is a parent set, and what you did, you took A cross A, you found the Cartesian product of A with itself. Now whatever relation I define, relation I define on this set, okay, that is, whatever relation I define, which is subset of A cross A, what I would say that those all relations are on set A. They are all on set A. R1 is defined on set A. R2 is defined on set A. Those all are defined on set A, and those all are subset of A cross A, and those all are binary relations on A. They are all binary relations on A. I hope you are following what I just now said. Okay. Okay, so let's study these relations in the binary relations. The binary relations, let's study in detail. So here what I have is, I have a non-empty set A on screen. You can check. I have a non-empty set A on screen, and what is n of A? N of A is 6. The total number of elements in set A is 6. So when I find A cross A, I have 36 elements, which you see on your screen. These are 36 elements you have. And what am I planning? I'm planning to define few binary relations on set A. Why do I call those relations as binary relations? Because I'm going to define relations on set A. That is, I'm going to define the relation from set A to set A. That is, I'm going to define the relations which are going to be the subset of A cross A. Remember, students, whenever you have a subset of A cross A, you will say binary relation on A. Suppose you have B cross B, and you define a relation on B cross B, okay, which is subset of B cross B, then you would say binary relation on B. If you have a relation which is subset of P cross P, then you will say the binary relation on P, and so on. So here, look at this R1. Here I'm writing R1. Okay, so there are total 3 relations you have here. So here there are total 3 relations which I have written, and we are going to talk about these 3 relations. And remember, all the 3 relations are binary relations. Why? Because they are subset of A cross. Look at this relation R1. What do I notice? I notice that the relation R1 is a subset of A cross A. Yes or no? Yes. See R1. In R1 you have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And see, so you have these elements you have in set A cross A. See, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So since all these elements are in A cross A, you say that R1 is a subset of A cross A. What do you say? You say R1 is a subset of A cross A. I'll write here R1 is a subset of A cross A, and then I will write therefore R1 is a relation on set A. No need to write binary relation. It is understood. It is a binary relation on set A. Okay. Now I'm writing something very interesting. You all have to follow this, and this will make the things more clear. See, here, see, 1, 1 belongs to R1. 1, 1 belongs to R1. Okay, so as 2 comma 2 belongs to R1, 3 comma 3 belongs to R1, all this. Okay, this can also be written as, okay, we can also write 1 comma 1 belongs to R1. Okay, we can also write this as, okay, we can write, we can write 1 R1 1. 1 R1 1. What is this one? This is the element from the set A. And this one is also element from set A. So 1 comma 1 can also be written as 1 R1 1. See, you can also write here, or you can write 2 R1 2. See, because 2 comma 2 also belongs to R1. Okay, now I write something. Just be very alert. See what I'm writing. I'm writing here R1 stands for, see, there is some meaning to R1. The relation R1 stands for, see, what does it stand for? It stands for is equal to. That relation R1 stands for is equal to. You can check. It stands for is equal to. Yes. See here, what you wrote? You wrote 1 R1 1. Now where you have R1, I want you to read is equal to. You have here 2 R1 2. Now where you have R1, I want you to read is equal to. So see what you will have. You will have 1 is equal to 1. 1 is equal to 1. 2 is equal to 2. 3 is equal to 3. 4 is equal to 4. 5 is equal to 5. 6 is equal to 6. And that is why all these elements, that is the reason that all these elements which you have here, 36 elements that you have here, from those 36 elements, the ordered pair which satisfied this relation is in R1. Those ordered pairs which satisfied this relation, they are in R1. Okay, there are 6 elements, there are 6 ordered pairs which satisfy this relation. Which relation? Is equal to. That's why they are here. Okay, now let's come to R2. See here what I have. R2 again, I noticed that R2 is a subset of A cross A. Yes, see, you can check all these elements that you have in the set R2. All these elements that you have in set R2, they are all present in set A cross A. They are all present in set A cross A. You can check 1 2 1 3 1 4 1 5 1 6 1 2 1 3 1 4 1 5 1 6 2 3 2 4 2 5 2 6. See, all are there. You check this, they're all there in set A cross A. So I will say R2 is a subset of A cross A. Therefore, I would say R2 is a relation. R2 is a relation on set A. What I would say? I would say R2 is a relation on set A. Further, I will say here, you can check, you can take any element, you know, say I have here 3 comma 4. So I would say 3 comma 4 belongs to R2. 3 comma 4 belongs to R2. Okay, or we can write the same as, see here I can write 3 R2 4, you know, or for that matter you could write here 3 R2 6, or you could write 3 R2 6. Why you could write that? Because 3 comma 6 is also an element of R2. You could write 5 R2 6. Okay, and remember students, there is something very interesting I'm going to write. And you know what? Here R2 stands for, the relation R2 stands for, I write here R2 stands for is lesser than, is lesser than. You can check wherever you have R2, wherever you see R2, just repeat this phrase, is lesser than. So see here, 3 R2 4, 3 is lesser than 4, 3 is lesser than 6, 5 is lesser than 6. So what I'm trying to tell you is, in all these elements, whichever element, whichever ordered pair satisfied the relation R2. What relation is lesser than? You wrote it in set R2. You wrote that in set R2. See here. You wrote for 1, 2, see 1 lesser than 2, 1 lesser than 3, 1 lesser than 4, 1 lesser than 5, 1 lesser than 6. You wrote all this because in all, the first component is lesser than the second component. See, you wrote. But you did not write any of these. You check this, you did not write this. No, you did not write this. Why? Because 5 is not lesser than 3, so it is not there. I hope you followed it. R3 we will write, R3 is also a subset of A cross A. I will write R3 is also a subset of A cross A. So therefore I will write R3 is a relation. It is a relation on set A. On set A. Okay? Because it is actually from A to A. It is a relation on set A. And here, what you can write, you can take few elements. See here, 5 comma 1. 5 comma 1 belongs to R3. 5 comma 1 belongs to R3. Okay. Then you have 6 comma 5. 6 comma 5 also belongs to R3. 6 comma 5 also belongs to R3. You know, this 5 comma 1 belongs to R3. You could write 5 R3 1. Here you can write 6 R3 5. And you know, students, what R3 stands for here? Here R3 stands for is more than or is greater than. R3 stands for is greater than. Okay, you can check all the elements which you have in R3, they are all satisfying the relation is greater than. You can check. Every first component is related to the second component under R3. Try to understand. All the first components are related to their respective second component under R3. 2 R3 1, that is 2 is greater than 1. All the first components are related to the respective second component under R3. 3 R3 1. 3 is greater than 1. 3 is greater than 2. 4 is greater than 1. I hope you followed this. Now I give you a problem for practice. You have to define a relation on this set A. Okay, you have to define a binary relation on A, which is R4. R4, you have to define a binary relation, and R4 will stand for, R4 stands for is a factor of. What does R4 stands for? R4 stands for is a factor of. So now you will all write R4. What is R4? Okay. This R4, once again, I repeat, R4, you have to define R4 on set A. define R4 on A. Okay, what does R4 stand for? R4 stands for is a factor of. Now, you know, when you define R4 on A, what does it mean? It means that R4 will be a subset of A cross A. Now, so you have to write all the ordered pairs. See, I made it so simple. I made it so simple. You have to write all the ordered pairs where you notice that the first component is related to the second component under R4. Under R4. So this is a practice problem for you. You will all solve this.